All right. Welcome to another episode of Common Lisp Study Group, folks. I'm your host, Ron Batum, at the Land of Functional Programming. Today, we're going to finally finish off some of our UI discussions for our flac metadata demo application. I thought, at the request of some folks, I went ahead and created a simple, design, kind of like a paper prototype of what we're trying to achieve here with our LTK application for the front end. I guess the best way to do this is probably show you guys my desktop so I could switch between windows. So if you guys give me just 1 second, I just need to clear up a couple of things to make things a little more. Yeah, that's fine. Okay, cool. So let me block this guy and then screen my desktop. And let me share my screen with my fellow Hangout people. Share down entire screen. Alright. So this is kind of the basic idea of the application that we're trying to shoot for. This is nothing more than a little window, 2 buttons, open file, exit application. It has some header information regarding bits per sample, min size, min block size, max block size, things that we've seen in the header that we encountered in last week. So I thought I'd go ahead and show you what we have so far. A couple of things that needs to be done here. Let's go here. And originally, we left off at something like this last week, where, as it turns out, that we were using a frame and having multiple frames like on top of each other. I did some digging last week after our stream last week, and realized that in order to accomplish this design, that it would be easier to do sort of a grid layout, which I was attempting last week, and I ended up having some issues. Turned out I was on the right track. I was just missing a couple of arguments on how to kind of set things up. So I went ahead and fixed that. And before we continue here, let me just quickly do this. Name. All right. And I went ahead and fixed it, and we got something from Wish that looks like this. So it's pretty simple. As you can see here, nothing really spectacular so far. It's kind of matching what we were trying to accomplish, as I showed you in that little paper prototype. To finish off some of the labelings, I was going to go ahead and complete this before our stream today, but I didn't get time, so I just went ahead and commented this piece out for some of the layouts. Sort of to give you guys some details on how to accomplish this sort of grid layout design in at least LTK. So if you guys are designing your applications in LTK, which not only is the Lisp Toolkit documentation a great source of information for you specifically on how to do it in Lisp and what command line and keyword arguments are there with respect to how it maps to the Tickle TK shell that we're connecting to. Because to review just very quickly what LTK does is it compiles our Lisp UI into a series of commands it passes to the Tickle TK interpreter, and that's the Wish shell that you're seeing that I had open earlier. And then it will go and use that to render the user interface. It's a very simple semi-interactive shell that gives you some basic functionality in terms of debugging. One of which I encountered earlier before our stream because there were some issues with how I had this written, mainly because in text boxes the text is a string, but the name, the label itself it uses a different it uses a different keyword for you to actually go and populate the text string. So let's go ahead and quickly uncomment some of these things. First, let's get into labels that I was showing you here. And another thing that that I wanted to mention, in the grid layout takes many options. Let me actually hide something here because I'm sharing my screen with my fellow Hangout members here. The grid layout takes many options. Let me show you what it shows in the mini buffer. It gives you a specific. It asks you to specify the widget, the row that you're trying to actually attach the widget to, and the column that it's trying to be attached to. Then it gives you a couple of keyword arguments that not all need to be specified, but because many of them have some defaults. But I'm using a couple of them here in various shapes and forms. One is the sticky. The sticky is basically, think of it like in a lot of UI toolkits, there's an anchor functionality that will, regardless of how you resize the window, this particular widget can stay in a fixed position. So this way, with respect to the window, if you move the window around, you resize it, that widget will never change its location. It will just stay fixed in that area. And it doesn't respond to window events to readjust itself or recalculate itself. Oftentimes, some folks who are starting off with UI design for a particular type of widgets, especially like buttons, they forget to do this, and their first weird thing that they look at is, why is my button resizing to the width of the window when I resize the entire window? It's because you didn't actually specify a fixed location and specify whether it should be sticky or not. So this will actually fixate those things. And for the sake of our application, the majority of our stuff is going to be fixed, which is why you will see sticky everywhere that I've labeled this. Even though we have, as you see here in our let form, a master frame that encompasses a lot of these, what's the word I'm looking for? These child widgets. When you lay it out into a grid, the frame and the widgets also need to be specified in a specific position. Otherwise, the UI will not get rendered with LTK. So here you see, in case of our button frame, I say, okay, this button frame is going to take up 3 rows in our grid, and has a column span of 3 columns. And we are going to fixate it in the northwest corner of the UI, which is the upper left-hand corner. Now, there are 8 directions, as you guys will encounter in TickleTK. LTK specifically has a keyword for each of them in a lot of the combinations. So north, south, east, west, northwest, northeast, southwest, and southeast are all defined. Sticky itself does not, at least from my experimentation, allow you to pass in a list of these. If you guys encounter that in code examples on the internet and you can port it over one-to-one, please let me know. I have not been able to get that kind of working with it, but that's something to be aware of, especially if you want a top-level frame that encompasses everything in the UI, and then it's able to resize as the window resizes. That's one thing I'm still looking into. From here, we could go through and just very quickly mention what widgets we've defined so far. One is open file and exit, obviously, and as you can see, I am incrementing the column number instead of the row number, which means that it is now aligning these guys on the same row, left to right, by using the same sticky direction, it will make sure that the spacing between the individual widgets are accounted for. Now, one thing to note here, if you want additional space between individual widgets, as I kind of mentioned in past episodes when we talked about LTK, there is padding that you can use to add space between particular widgets. And there's two types of padding. One is a global padding with respect to the frame or the widget and the window that it's being rendered, and that's pad X and pad Y. And then, as you see here at the stream info section title, I'm using the internal padding, which adds a little space in the window for a given a widget. This allows, if you wanted a text to be centered in a button, for example, or in a grid cell within TK, you can certainly do so, and your padding will be only affecting that single cell and nothing else globally. So very quickly, going uncomment these guys here for the min block size and max block size. Go ahead and compile this and run it, and we'll see when we run. Oops, sorry. When we run a wish shell, that we have the startings of our application. And we can actually go ahead and populate the info that we grabbed the other day. And just to show you that this all still works, if we go in and we cancel, nothing gets populated in the upper right hand corner, but of course if you go in and specify a particular flac file, you'll see that our dialog will get the full flac file populated in the header and the window title. One thing that you probably may have noticed is why is when we resize the window, everything is fixed right in the upper left-hand corner. This goes back to what I was talking about in terms of our fixating of our widgets in the upper left-hand corner and how they will not change with the rest of the window. And we're going to use that for now, just to make things a little simpler, because again, this is going to be a fairly simple application for the front end. So let's go ahead and add. Let's make sure we can do this, and this. And now we are going to go ahead and quickly do this. Add that. Oops. Too many quotes. That means I am missing something. There is the error which gave me show details. It's not giving me any details. What was debug from Wish? Okay, that's fine. I'll go and make those into labels for now since we need them anyway to be read-only. And then I'll deal with the input part of this later on. I want to do this, but sometimes. Now we have all this assigned. Okay. So how are we going to actually get these labels populated? Now you probably remember that we tried this last week. We went ahead and we read in our flac file. Just to reiterate it here for folks who are going to probably watch this specifically. And when we explore this, we notice that our flac file's first tree, if we go into stream info, you'll see that in the data block section of it, we can actually get some information regarding sample count, sample rate, minimum block size, maximum block size, and so forth. So we need to be able to actually access this information. So in our block, our metadata file, we can actually go and look into this information. So let's go into that. Metadata. Okay. And you see that in we have this top level metadata block, and we need to get the first information of the stream info. So let's go down to stream info, and if I'm not mistaken again, it is with slots. I do min block size, max block size, per sample from our and this is coming from our block stream, so I have to go and mention. We open up our block stream file. This is going to be in open this up again. This is in first tree. Yeah. This will be and the stream info of our first tree. format next block size bits in block size and bits per sample. And we specify in block size. Sorry. Min block size, min block size, and our bits per sample. Sorry, I gotta go remind myself how I did this. Read the flac, read flac stream. I think that's what I have to go and look at. That is in right there. I'm just being an idiot. So let's go ahead and define a quick parameter here. So we have our flac file after we read it in. For folks just tuning in, this is just to show you guys how to access this information. Just adding some global variables here into our REPL. I'm reading in the flac file, which will give us the parse tree. And from the parse tree, what we could do is we can grab the stream information from the parse tree, as we saw there during our inspection. So all I have to do is go up to this, and let me just make this a little easier for folks watching here. Awesome. Flac file. This is going to be the softmax missing from the object metadata block. What size is in the metadata block? Okay, let me just show you guys that. Okay, so this obviously, how do I wrap? Info. Sorry. Okay, made this into stream dash info. There we go. And then from there, we can actually grab the from the metadata block data. Again, SP round metadata block data. And we see here, this is what we're trying to access. So now we can grab what we need, so we need to go do this. So if you recall, we created this global metadata structure. This metadata structure is essentially the flac file that we just did here in this example. This will hold the entire flac object. So really, this should be renamed here. This is current flac file. So this is now that. And when we read in the file, this has been populated, but now we need to populate everything else from this, which is mainly the information that's in here, this label. Now, this is where some things that might be, I'm going to just go ahead and mention them here. I don't believe, you may have noticed that sometimes I go ahead and I define the text for a given label here, but in our case here, for the bits per sample information, the minimum block sizes, labelings, and the maximum, which will display that the actual data that we just retrieved from the object, those have not actually been defined here. And the reason for that is because since those are actually going to be changed based on what file's been opened, ideally you need to have some actions actually attached to this, so that when a file gets opened, it triggers the population of those widgets. So in most GUI systems, it's event driven. When an open file happens, the content of the file is passed as part of the event that's then going to trigger some other event handler to actually go in and do the population. So that's what we're going to have to do here. We're going to have to define some actions using LTK's action handlers to basically handle what happens when a file gets opened. Let me just pull up something here in case I'm if I'm not mistaken, it is bind. Yeah. So So bind takes in three operations. The widget, three arguments: the widget, the event, and what should happen, right? We're going to go ahead and, for simplicity's sake, we will we're going to have a single bind event, mainly on the open file button when a file is selected. What should happen? This is going to require us to possibly define our own event, but ideally it should be just an open file contents. Now, I will say up front that this is going to be our live coding portion of this session, because this is a section of LTK that I'm not as familiar as I'd like to be. But folks who are watching and have questions while I'm doing a little digging, feel free to go ahead and ask away. I'm just trying to figure out very quickly what the event that's being thrown by the dialog box is. So just give me just 1 minute. Where are you? So we can use event generate. Let's see if that's. We can do that. I'll close this guy out. And then what we want to do is LTK event other stuff is here. Event character, event root X, height, and mouse button. That's only for actually doing key press events. But this one is going to be an open file, and we need to pass in the file. Let's see what happens here. Enter mouse pointers. Don't, that's not it. And for any type of can be defined by functions bound to it. So we could just go ahead and do this. We could just go ahead in this window. Let me just delete this guy for now. So I can show you how to set this up here after. We could bind to our details. Not necessarily our details pane. We could do it for each of our labels. We could do command file open, and we could do a lambda here, and we really need to just ignore that event, because by the time we get this, our global metadata structure will be, our file will be populated, so we can just grab the information that we need from that, which is the slots that we showed earlier. We just grab that code. then we could just go ahead and populate each of these instances. So mainly do set F. I think I could do a set F here. We'll see. The labels. The widget of PS info, the bits per example, text, block size, block size. And since we have named this minimum and maximum, since we have text max. Messed up something here. Let's go double check here. I was putzing around with the there we go. It's loaded. Delete this guy here. Okay. Slide 35. I'm going to wish is telling me. Oh, right. Not just bind, it's LPK bind. What is this here? Bad event type file event. No, I thought we could define our own specific event type. Let me see. I must have messed up the custom event type. Okay, let's see here. Get open file type below. guys are wondering what I'm doing is I'm looking for essentially the equivalent to, in TK there's a way of actually allowing you to specify your own custom events. It's called event generate, and I'm just wondering if this is here and I'm just messing up I just didn't register my event correctly, which I didn't actually because I'm binding it. I didn't register it just yet. Canvas, widget stream, after cancel, create, line, image, tree select, again, quality, create window, top level. So all list boxes related. Search text tree promote LDK. Not money there. This may not be available. I'm wondering how we would go and simulate this. Let's go to is the way to look at do this outside of this loop here for now, so I don't go mess things up. What was the command going to the source code? It was my apologies, folks. I just started using do Emacs, so a lot of key binding stuff that I used to know by muscle memory are kind of been screwed up a little bit, and I'm still getting used to this. There is a command to go and look into the source code for a third-party Lisp library. I'm forgetting the key binding it was. Is it something I propose? Just look for the symbols. Maybe that's probably easier. Symbols, but doesn't give me anything related to defining my own. There's a way of defining it. What is that? information. That's what I was looking for. Def struct event. Where are you? Goodness. And here is a make event. What is that thing? It is the best way to grab it. It would be this would be a dirty hack if I do this, but this can work also. This doesn't work. To simplify things, because it looks like event register isn't actually defined here, so I'm going to have to go do a digging. But there's multiple ways of skinning a cat. We can actually go and instead of binding it like this, which we should be doing, we can actually throw it, for simplicity's sake, in the open file dialog, which we could specify here that we have here. We'll take all these buttons and move them to the end, so that way, since this is a lot star, they'll be accessible. Not going to mention that this is the best way of doing things, but certainly this will allow us to get a functioning application for the time being. Okay. That's what I want to make sure. So now we have all those defined. We can grab this, cut it, and here. Paste it. That's it. Move this here because I don't like spanning out that entire screen. Although for simplicity's sake, it might be useful to do that. All right. So now let's go ahead and get this guy out. Because now, one warning. What is the warning? Undefined variable. What? Oh, thank you. I forgot to load this into the image. Now this should be okay. What? This is intern, but it's not defined. That's right. Never mind. Do this. Load it up. Let's see. It's currently unbound. Still currently unbound. Okay. Let's do this. Don't actually really need this anyway. What we really need is, since we're not going to be using multiple of these anyway, let's delete this check because we're checking that later on. And let's bring it down here. Oh, right. Those are instance variables. This guy needs to be that, and then we need to actually go and make these guys. Go ahead and do that. The main reason I'm doing this is because of the make things a little bit clearer. Lisp tends to would be able to figure out which instance that we're going to, but make the reading of the code a little bit more clearer for folks. Just make sure that there aren't any questions happening here. Cool. Dialog, home directory, why it's showing. And you see, finally, our final application being able to read in the minimum size and maximum size of this object. We can, of course, switch between different flac files, sweeter than roses. We'll still load up some of the information. Now, of course, I haven't actually added any error handling in here. So this isn't completely done because, as you can see right here, while the button clearly changes, the minimum size and maximum size of these samples are still not getting populated the way they should. So I will at this point say that this is still a functioning app right now. Again, it's not, there's still bugs in it, but it's still giving us a lot of the basic of the application design that we can get some initial feedback from folks when they start looking at it. But there's still a couple things remaining before even with this buggy application that we'd want to encounter and still fix. One is well, okay, how do we, for example, how do we build our application? Like get it ready for deployment in binaries, and how do we set it up so that people can actually use this, because this is an LTK application, right? You might be wondering, well, what actually gets delivered? Because this kind of assumes, since it's using Wish behind the scenes, that you will have some version of TK on your system that this thing can actually go and hook up and look into. Those are all very good questions. These are, that's a longer discussion on how to handle deployment, because that requires us to start talking about, different build tools that are busy beyond ASDIF, because ASDIF can, if you give build operations, it will build your application, and it will, in many cases, dump your Lisp image and, set up the main endpoints and then create a binary for you. I mean, it's the same thing. What it usually does behind the scenes, and I defer to our longer discussion of as-if that we had in the past. It hooks into the specific build instructions of the given Lisp that you're trying to compile to, and use that to actually go and set up the appropriate compiled binary. In the case of using LTK, though, this is something I'm not as familiar with. When I'm usually, when I'm building Lisp applications, I'm building command line applications. This is the first GUI application that we're going to have to go and dig into, and that means obviously that we have to think about these things in terms of third-party dependencies, how the ultimate applications gets zipped up and set up for installation on another machine. Of course, if you're using, like I am, a MacBook, that means you have different platform-specific dependencies. Other folks with Windows might have different platform-specific dependencies. And usually, if this was a commercial endeavor, you would want to set up a CI system that would compile these guys into multiple platforms, of which there are many available now that would allow you to set up scripts to compile to different Lisps. One that I've been playing around with is Travis CI. That actually goes in, at least for me, for the stuff that I've been trying to putz around with, it does have the ability to compile to for SBCL and for Clojure and so forth. But like I said, this is going to be part of a longer discussion, of which we just kind of ran out of time here. Are there questions in terms of what we've done for this application, whether it be the front end, the back end? How do we design the metadata objects, or in general protocol specification implementation inside Lisp? So in this case, you would think that we implemented the flac protocol. Now, we didn't implement a couple of things in here that for folks who think that this is a complete protocol, it's not. Fortunately, that's because of samples. One of the difficulties of implementing such a protocol that's complex as flac is finding samples that are complete enough for you to actually go and test it to make sure that you implement different parts of the specification. Now, we've implemented the majority of the metadata that's available to us based on free samples that we found online. That's things like the stream info, the picture, the padding, and a couple of others. But Q sheet and things where you're actually downloading a full album, we have not implemented, primarily because, again, you would have to find a sample to actually go and implement it, or you would have to find a third-party editor where you can actually create such samples to actually go and get such a testing set, so you could verify that you're reading it in correctly. Again, error handling is something that this application that I'm going to check in. The version that's currently on GitHub, that was from last night. I need to add these fixes in that we just done during the stream. And next week, what we'll start talking about is well, how do we bundle this guy, like I said earlier, and then how do we set this up for ultimate deployment for folks to actually be able to use it. Are there questions? Oops, let me go and switch to All right. Well, thanks so much for joining us on the stream. I thank my fellow Hangout regulars, and I'll see you guys next week.